Okay, well today we're going to talk about the integral test for series, which is just another test to determine if a series converges or diverges. Suppose that a series is positive, decreasing, and continuous on the interval k to infinity. If the integral from k to infinity is convergent, then so is the series. If the integral is divergent, then so is the series. The trick to the integral test is that it has to be something that you can actually integrate. So if it's something that you can integrate, then you can use the integral test. So we're just going to do the integral from 1 to infinity of 1 over x dx. And remember, this is an improper integral, so we need to do the limit as n goes to infinity from, well, let's use b, from 1 to b of 1 over x dx. Well, the integral of 1 over x is just the natural log, so it'd be the limit as b goes to infinity of the natural log of x from 1 to b. Well, that's just the limit as b goes to infinity of natural log of b minus natural log of 1. Well, if I fill in my infinity, natural log, the limit is natural log is b goes to infinity, well, that goes to infinity, minus the natural log of 1. I don't really care because infinity minus anything is infinity, so that's going to be divergent. Okay, I'm going to do the integral from 1 to infinity of 1 over x squared dx. Well, that's the same as the limit, so again it's an improper integral, of b to infinity, 1 to b, of x to the negative 2 dx. So if I integrate this, I add 1 to the exponent and divide by that, so I would have x to the negative 1 from 1 to b, and it's the limit as b goes to infinity. So that is negative 1 over b minus negative 1 over 1, the limit as b goes to infinity. Well, the limit, I can do them individually, of negative 1 over b, the bottom's bigger than the top, so the limit goes to 0, plus minus 1, so it would be 1. So because this converges to an actual number, then the series converges. And then here's one more theorem with the integral test. It says if you use the first n terms to estimate the value of the series, the error is less than the integral from n to infinity. So I feel like this didn't give us enough information. I think it's actually, there needs to be more to this question. Let's just kind of make it up. Find the error when using the series to estimate the first 4 terms. Okay, so if I use this to do the first 4 terms, I would do 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, and that would be it. So it would be 1 plus 1/4 plus 1/9 plus 1/16. So the error would be less than the integral from 4 to infinity of 1 over x squared dx. Well, we've already integrated this, and we got negative 1 over x from 4 to infinity. Basically, that looks like an 8. Infinity. So that's negative 1 over infinity plus 1/4. Well, that's 0 plus 1/4 would be 1/4. So we could say that 1 plus 1/4 plus 1/9 plus 1/16 is less than 1/4.